power of AI: predicting, preventing, and recovering from natural disasters. Numerous unexpected natural disasters, such as earthquakes, fires, and floods, resulted in significant losses, particularly in areas without effective disaster management protocols. However, if we anticipate these events, we might lessen their influence. Similarly, scientists are using AI-driven systems to anticipate natural calamities precisely. Artificial intelligence has proved helpful in several areas, including customer service, commerce, and healthcare. And now, scientists have discovered that it is possible to anticipate natural catastrophes using AI. Using high-quality data, AI can predict the onset of various natural catastrophes, potentially saving thousands of lives. To help lessen the damage caused by natural catastrophes, local governments may deploy automated responses, early detection, and forecast systems. With modern equipment, first responders are being assisted in responding more quickly while warning residents and initiating mitigation. As artificial intelligence, AI, develops, sensors become more prevalent, and data collectors grow, prediction and detection systems are expected to become more accurate and effective. However, not all disasters are equally accessible to AI, and the technology is most trustworthy when analyzing incidents where the underlying causes are clear. There is ample data to train the algorithms. The occurrences are frequent enough that the model's predictions can be compared to reality and improved. A few of the natural calamities that AI may anticipate are earthquakes. Seismic data may be used to train AI-powered systems to assess the size, patterns, and locations of earthquakes and their aftershocks. Researchers are using deep learning algorithms to examine enormous amounts of seismic data. Artificial intelligence can evaluate the frequency and patterns of earthquakes using seismic data. This knowledge might help make earthquake predictions. For instance, Google and Harvard are developing an AI system to predict earthquake aftershocks. Researchers looked at more than 131,000 earthquakes and aftershocks to build a neural network. The neural network surpassed conventional approaches in predicting the locations of aftershocks when tested on 30,000 occurrences. Similarly, other academics are creating their program for predicting earthquakes and aftershocks. Future earthquakes may be predicted so that officials can start the evacuation process. Japan is actively studying satellite images of the Earth to anticipate natural calamities. Artificial intelligence, AI-based algorithms scan photos for changes to determine the possibility of catastrophes like earthquakes and tsunamis. Additionally, these technologies monitor aging infrastructure. Artificial intelligence, AI, technologies can detect structural deformations and reduce the harm brought on by collapsing structures, including buildings and bridges, as well as settling roads. Floods. With the help of Google Maps and Google Search, the company is creating an artificial intelligence framework to anticipate floods in India and warn users. Flood simulations and rainfall records are also utilized to obtain data for the AI system's training. Similarly, scientists are developing AI-based systems that can learn from rainfall and climate data. These systems are being tested with flood simulations to see whether they can predict floods more accurately than conventional approaches. An alternative is to employ artificial intelligence, AI, to track urban floods. Twitter and other mobile applications are being used by researchers at the University of Dundee in the UK to gather crowdsourced information on urban floods. The data that the AI identifies includes pictures as well as details about a location's circumstances. These kinds of systems are usable. The question is, can AI outsmart Mother Nature herself? Hurricanes cost millions of dollars in property damage each year. Consequently, meteorological agencies are looking for techniques to predict better, track, and assess the intensity of natural disasters like hurricanes and cyclones. The responsible authorities may save more lives and avoid property damage using more precise forecasting tools. Hurricane Harvey was recently tracked by NASA and Development Seed using satellite images and machine intelligence. The device performed 6 times better than conventional techniques, making it possible to follow the storm every hour instead of every 6 hours as with conventional techniques. Technology improvements are thus helpful in storm monitoring and forecasting, which may help with hurricane mitigation strategies.
Volcanic eruptions.
Scientists have worked to create methods for forecasting natural disasters like volcanic eruptions for a long time. Scientists are now training artificial intelligence to recognize small ash particles from volcanoes. The ash particle shape may identify the kind of volcano. Such developments could help with eruption forecasting and the creation of protective measures against volcanic hazards. The question is, can AI truly forecast the unpredictable? To predict volcanic eruptions, IBM is developing a machine named Watson that will combine seismic sensors and geological data. IBM intends to forecast the locations and magnitude of volcanic eruptions via Watson. These programs could help to reduce the number of deaths in areas close to erupting volcanoes. Fires. As they are looking for the flames, firefighters in the hilly area may not know whether the fire is a difficult climb until they arrive. Some locations need a helicopter or aircraft because fire trucks cannot enter there, and it would take too long to go there. They will be able to more rapidly and accurately identify and target sputtering flames with technology. This entails knowing when to send an aircraft crew, sparing valuable time, and grabbing lightning-struck trees while smoking. The San Antonio-based N5 AI-powered system uses sensors strategically positioned across the target areas to detect chemical traces, smoke particles, and gases in the air and record temperature information. A cloud-based technology analyzes the data and updates digital maps while providing warnings and locations to responders via text message. The algorithms analyze sensor inputs to discriminate between smoke from dangerous fires and non-harmful sources like home chimneys or campfires. A spreading fire is more likely to be indicated by several sensor activations. Therefore, checking to see whether many sensors light up may also be helpful. But can AI truly decipher the chaos of a raging fire? Tsunamis. Tsunamis pose a serious hazard to coastal communities all over the globe since they are often caused by undersea seismic activity. The potential of artificial intelligence in tsunami prediction and mitigation is being steadily shown. Artificial intelligence, AI, systems may give early warnings and assist in predicting the scale and effect of approaching tsunamis by analyzing seismic data, marine sensors, and previous tsunami records. AI is being used in Japan, a tsunami-prone nation, to track undersea activity and examine data from sensors and buoys in the ocean. AI-powered systems can inform coastal populations when earthquake activity and water behavior are out of the ordinary, providing them with vital time to evacuate and minimize possible harm. Additionally, projections of the height of tsunami waves are becoming more accurate thanks to machine learning algorithms, which support preparation efforts. There are still issues, however, since the intricacy of undersea fault networks and the scarcity of historical data for certain areas affect how accurate these projections are. Landslides. A landslide is another natural calamity that may have disastrous effects, particularly in hilly areas. AI is useful for identifying the causes of landslides and identifying risky locations. AI algorithms can pinpoint areas with increased landslide danger by examining topographical data, weather patterns, soil conditions, and previous landslide incidents. For instance, AI-driven systems monitor rainfall patterns and ground movements in places like the Himalayas, where landslides are a constant concern to send out early warnings. These technologies can provide local authorities with real-time information, enabling road closures and evacuations when required. Additionally, AI can help create predictive models that account for the effects of climate change on rainfall and soil erosion, improving the accuracy of landslide forecasts over time. The requirement for thorough and current data and the difficulties of forecasting the precise time of landslide occurrences remain despite the advances in employing AI for landslide prediction. Artificial intelligence, AI, will become increasingly important in lessening the effect of landslides on vulnerable populations as technology advances and data collecting improves. Although there are many methods for utilizing AI to identify catastrophes, this disaster analysis system still has significant limitations with AI. One of the limitations of artificial intelligence is that it can compete with humans in terms of workload and processing speed, but not in terms of forecast accuracy. There are several circumstances in which AI may err. The data sent into the system is gathered by people, which may not be correct. As a consequence, findings produced by AI might be inaccurate. In addition, past AI adoption patterns indicate that humans tend to depend too much on AI. Researchers will thus need to do several experiments to make sure the technology is reliable and appropriate for usage in the real world. The data used in artificial intelligence is based on historical records of natural disasters, which is another issue. Due to the changing patterns and magnitudes of natural catastrophes like floods and earthquakes, AI-powered applications cannot handle them. Additionally, there is no mechanism in place for existing AI-powered applications to take the effect of climate change on natural catastrophes into account. As they are taught on historical data, AI systems cannot assess the impacts of climate change. Artificial intelligence thus struggles to foresee long-term trends in various natural catastrophes driven by climate change. Artificial intelligence and machine learning, two examples of contemporary technology, will be useful in catastrophe prediction. However, overcoming the technology's shortcomings is crucial before using AI in practical applications. Therefore, researchers must focus on finding solutions to current artificial intelligence problems. Artificial intelligence, AI, applied to forecast natural catastrophes would save millions of lives. Greater knowledge of the scope and patterns of natural disasters like floods, earthquakes, and tsunamis will also be aided by the datasets examined by AI-powered systems, which will help create better infrastructure in disaster-prone regions. To ensure the protection of its inhabitants, government organizations must employ AI to foresee natural catastrophes and effectively monitor them. Can AI truly replace the human touch in times of crisis? Do let us know in the comment section below. That is all for this video. We will be back soon with another informative video. Don't forget to like and share this video. Until next time.